In this case, how many sources are there? We have 1, 2, and 3. 3 sources. But there is no meaning for the dependent source. In case of the superposition theorem, we have to find out number of independent sources, not the dependent sources. In this case, we have the 2 dependent sources. This is one, this is other. We have to consider the 2 cases. For case 1, we will calculate current in this branch, current by considering this source, and secondly, we will consider this source. Is it right? When we will consider this source, we will calculate current I, which is current in 3 ohm, and then next we will consider this source and we will calculate current in the same branch. Here, I will start the discussion. Focus properly. Case 1. Case 1. How is the case 1? We will consider a 24-volt source. Just right. And 7 ampere source is replaced by its internal resistance. Is it right? Now look at here, I will draw the next figure. Whenever both sources are existing, this current is I. But whenever I am considering this source, it may not be the I. It will be the different value. If it is a different value, this will be the different value because same is I. And when we will consider this source, again this value will be the different, and if it is different, this value will be different. Just we have to consider number of independent sources in case of the superposition theorem. केस 1 में हमने इसको कंसीडर किया, केस 2 में इसको कंसीडर करेंगे. ये डिपेंडेंट सोर्स है. अगर ये भी सोर्स नहीं होगा, ये भी सोर्स नहीं होगा, तो इस सोर्स का कोई मतलब नहीं होता, बिकॉज इस केस में I 0 हो जाएगा, I 0 तो ये 0 हो जाएगा. देयर इज नो मीनिंग फॉर दिस सोर्स. इज इट राइट? नाउ लुक एट हाउ विल बी द फिगर. Its figure will be something like this. This is current source. This current source will be replaced by open circuit. तो इसके टर्मिनल यहां से और यहां से हम ओपन रखेंगे एयर में. Then how will be the figure? Figure will be something like this. Is it right? This is plus minus 3. I will call it as IA, क्योंकि ये दोनों जब एग्जिस्ट होंगे ये I होगा, लेकिन एक ही एग्जिस्ट होगा. दिस विल बी द IA. ये एग्जिस्ट होगा, उस समय उसका नाम दूंगा मैं IB. Is it right? Or maybe I1. This is 24 volt. Is it right? This is 3 ohm. This is 2 ohm. Figure will be something like this. In what value we are interested? We are interested in the current in this branch. और इस ब्रांच में जो करंट है यही नाम है IA. Yes, we are interested in this IA. इस IA में हमारा इंटरेस्ट है. यूज एनी मेथड, क्योंकि इसमें रिडक्शन नहीं चलेगा, क्योंकि ये डिपेंडेंट सोर्स है, ये सीरीज या पैरेलल में नहीं आएगा किसी के. तो इसको केवीएल अप्लाई करते हैं. देयर आर नंबर ऑफ वेज. दिस इज अनदर वे. Here we will apply the KVL, that is Kirchhoff's voltage law. यहाँ पे KVL अप्लाई करते हैं. Now here I will mark the polarity, क्योंकि इसके हिसाब से इसका डायरेक्शन लिया है. I will name this current as IA again because this complete path में same current है. It will be plus minus. This is plus and minus. This is already plus minus. This is plus and this is minus. Now apply the KVL because we can use any method. जिससे पहले वाला जो method हमने discuss किया, that is reduction technique. We can use the reduction technique in this case also, but it becomes complicated whenever we have the dependent source. That's why we are using the KVL or other method, applying KVL. Applying KVL to above figure. If we will apply the KVL to this figure, we get what we get. I will write here. I will start from here. How is the KVL? We are starting in clockwise direction. Negative to positive, that is a plus. Plus. How much is the value? Negative to positive plus 24. Then positive to negative minus. How much is the voltage across this? Its resistance into its current, it is 3 into IA. Then positive to negative minus. How much is the voltage across this? 2 into IA. Positive to negative minus. How much is this voltage? 3 into IA. 3 into IA, which is equal to 0. Simplify this equation. If I am shifting all the IS to the next side, in that case equation will be this 24 is equal to 3 and 3, 6 plus 2, that is 8. Is 8 IA. Therefore, IA is equal to how much? 24 divided by 8. 3 amperes. Is it right? 3 amperes. But how is the direction here? It is forward. Generally इस मेथड में डायरेक्शन का सोचने का जरूरत नहीं पड़ता है, because whenever direction is opposite, sign अपने आप माइनस आएगा, because we are applying the KVL. Is it right? This is 3. It is forward. Now we will consider the case 2. We will consider the case 2. Now in the second case, we will consider the 7 ampere source. Considering 7 ampere source and replacing 24 volt by its internal resistance. Its internal resistance. How will be the figure? It will be something like this. ये तो रहेगा. This is 2 ohm. This will be something like this. This is plus minus. This is 3 IB. I will call it as IB. और इस केस में ये करंट का नाम हमने ऐसा डायरेक्शन दिया है. This will be IB, क्योंकि ये एग्जिस्ट होगा. दोनों I था, एक एग्जिस्ट था, उस समय IA था, ये एग्जिस्ट है, अभी इसका नाम हमने IA दिया है, सॉरी IB दिया है, बट डायरेक्शन इज द सेम. आई हैव टेकन दिस डायरेक्शन एज सेम. कंफ्यूजन नहीं चाहिए. Is it right? I will take the more number of the problems on the different. This is the first. No need to bother. This is 7 amperes. इसका डायरेक्शन पता है? इसका डायरेक्शन कैसे है? अपवर्ड है. I will call it, this is IB. I will call it as I1 maybe, or something different name. This is IA is given, IB is given. I will name it as IC, and this current is also there. I will name it as ID, because I am planning to use, जब भी करंट सोर्स होता है, बेटर टू यूज द नोडल एनालिसिस. हम मेश एनालिसिस भी यूज कर सकते हैं. यहाँ पे एक लूप हुआ ये, एक लूप हुआ ये. इसको केवल अप्लाई नहीं कर सकते, बिकॉज हियर इज द सोर्स. दैट्स व्हाई वी हैव टू यूज द सुपर मेश. This one equation we will get from the super mesh, other equation we will get from this current source branch. In place of that, use the nodal analysis method. This is the node X. Its potential is Vx. This is the ground node. Give any name. IA, IB, इसलिए A को avoid किया मैंने. I have taken it as X. This is incoming, and this is outgoing, and this value is the 2. Now we can apply the KCL. Applying KCL at node X. X पे KCL apply करना. Means what I am trying to say, calculate current in the required branch by using any method. Previously हमने reduction method use किया. You can use the mesh analysis. You can use the nodal analysis. You can use any other method you are aware. But Consider only one source at a time and calculate its current. Are you getting me? This is the philosophy in case of the superposition theorem. Superposition theorem का philosophy क्या कहता है? Consider only one source at a time, calculate its current, and depending on the direction, add it or subtract it. If we are applying the KCL here, these are the two incoming. This is the outgoing. This equation will be IB plus IC, which is equal to ID. How much is the IB current in this branch? 0 minus Vx divided by 3, which it is minus Vx divided by 3 is the IB. How much is the IC? 7. How much is the ID current in this branch? Vx positive to negative. Vx positive to negative minus 3 into IB divided by resistance of this path, which is 2. Simplify this equation. If we are simplifying this equation further, it is minus Vx upon 3 plus 7, which is equal to Vx upon 2. This is Vx upon 2 minus, it is 3 by 2 into it is IB. अगर ये Vx को इस साइड पे शिफ्ट करते हैं, how will be the equation? Vx को कॉमन लेंगे, it is 1 by 3 plus 1 by 2. इस तरह ये प्लस हो जाएगा इस साइड पे. Then minus 3 by 2 IB, which is equal to 7. This is the equation number 1. Case 2 में equation 1 आएगा. लेकिन unknown कितने हैं हमारे पास? How many unknowns we have? We have the two unknowns. One unknown is the Vx, another unknown is the IB. One unknown is the Vx, another unknown is the IB. Now find out another equation which gives the relation between I1 and IB. Vx and IB. Already we have obtained that IB. So what should be our second equation? Our second equation will be something like this. How is the second equation? This IB is equal to this equation we have already with us. This IB, which is equal to how much? It is minus Vx by 3. It is minus Vx by 3. This is the second equation. Otherwise, I will simplify it. I will shift this value on this side. This 3 IB, which is equal to minus Vx. Or if I am shifting the Vx on this side, then it will become plus Vx plus 3 IB, which is equal to 0. Otherwise, you can shift this value to the next side. That will become minus Vx minus 3 IB is equal to 0. That is the equation number 2. Is it right? We have two equations. This is one. How much is the value of this equation? First इसको value simplify करते हैं. 1 by 3 plus 1 by 2. How much is the value? 1 divided by 3 plus 1 divided by 2.
0.83.
Which is 0.83. Is it right? This value is 0.833 Vx minus, how much is the 3 by 2? 1.5, I guess. Is it right? Minus 1.5 IB, which is equal to 7. This is the equation number 1. हमारे पास अभी दो equations है, दो unknowns है. Find out the Vx and IB directly. हमें IB का value मिलेगा. If I am using this calculator, here I am using this calculator now. If I am using this calculator, we have the two equations here. This is equation number 1. This is equation number 2. Here, if I am using this mode, I will come to the normal mode. This is mode. I will go to the equation. This is, I will press 1. Unknowns. We have the two unknowns. A1. How much is the A1? 0.833. This is I1. How much is the I2? That is, next unknown, which is minus 1.5. This is minus 1.5, which is equal to, how much is the constant? Constant is the 7. I will put the 7. Then, how much is the A2? Thus, 1. How much is the B2? Plus 3. How much is the C2? That is constant, which is 0, which is equal to, this X is 5.25. This Vx is 5.25 volt. How much is the Y? Now look at what is y? IB, and this IB is minus 1.75 amperes. Is it right? देखो जब हम मेथड यूज करते हैं उस समय आंसर प्लस या माइनस आ सकता है. Is it right? Then how is the final answer? The load current is equal to, it is how much? IA plus IB. प्लस ही लेना है हमेशा, बिकॉज मेथड से जब कैलकुलेट करेंगे अपने आप पोलैरिटी मिलेगी. हाउ मच इज द IA? IA we have calculated, it is 3 amperes plus. How much is the IB? It is minus 1.75 amperes. Is it right? दोनों का डायरेक्शन सेम रहेगा, ऐसा भी आप सोच सकते हो. इसमें भी डायरेक्शन फॉरवर्ड है, इसमें भी डायरेक्शन फॉरवर्ड है, दोनों केस में डायरेक्शन फॉरवर्ड है. Is it right? In both cases direction is forward. तो ऐड कर सकते हैं, इसलिए मैंने ऐड किया IA plus IB, but its value is found to be negative. That's why it is 3 minus 1.75 amperes. And how much is the final answer? 3 minus 1.75. Yes, anyone?
1.25.
1.25 amperes. But how is the direction? Final direction किस तरफ है? Look at which one is the bigger value. ये IA ज्यादा था या IB ज्यादा था? हमारा IA ज्यादा था. It is same as IA. And how is the direction of IA? Forward. ये भी value इसका भी direction रहेगा forward. Its direction will be the forward. And this is about this particular problem. Today I will stop here and I will scan all these copies and I will upload. At the same time, if time permits, I will upload the videos in my YouTube channel, as well as today itself I will upload all the notes from day 1 to till date in Google class.